This time in the Planet Earth podcast, protecting our streets from flooding. Welcome, I'm Richard Hollingham, and I'll also be reporting from the Norfolk Fens, where scientists have set up an unusual experiment.
It's got all the elements you'd expect from a normal weather station. For example, we're measuring temperature, relative humidity, radiation and that sort of thing. But then the bit that looks a bit like a whisk is the more advanced part of this.
Britain's wet summers highlighted a problem facing towns and cities: urban flooding. Rather than soaking through the soil, water in built-up areas is blocked by concrete, tarmac and tile and can overwhelm the drains and flood. But there is an alternative, at least in some areas: SUDs, sustainable drainage systems, with some neat ideas for urban planners. Well, I'm at a typical street. It happens to be on the edge of Keyworth, on the outskirts of Nottingham, beside a row of detached 1960s houses with their driveways going onto tarmac roads. And over the other side of the hedge, the campus of the British Geological Survey. And with me is Rachel Dearden, who's a hydrogeologist for the organisation. Let's talk about then the flooding. What happens in an urban area when it rains? Where does the rain go?
Well, the rain falls on roofs and pavements. It then flows into the drainage network, and hopefully it would flow into watercourses from there. But unfortunately, if it rains really quite intensely, then essentially these drains become overwhelmed, they surcharge, and actually water comes back out of them, and then we get this problem of urban flooding.
And this is a particular urban problem, because in the countryside the point is the water would soak into the ground or end up in the rivers.
Exactly, yeah. Where the ground is fairly natural, the rain soaks into the ground and disappears into the aquifer below. But in the urban area, we get this impenetrable covering of concrete, hardened surfaces, buildings, and so the water has no option other than to run off, and then we have to deal with it.
I mean, this is a problem that's obviously been around for as long as we've had tarmac and concrete, or any hard surface, really. But I suppose now there's greater concern about this intense rainfall we seem to be getting.
That's right. Rainfall does appear to be becoming more intense. And not only that, but urban areas tend to be getting bigger, and we have more impermeable areas. People are tarmacking their drives, and so there's less potential for the water to escape into the ground, and there's more water going into our drainage systems.
So tell me about SUDs. What is it? What's the idea?
Right, so sustainable drainage systems, they basically try to deal with the rain where it falls. So they try to prevent these flows from being generated in the first place. SUDs tries to mimic the natural conditions that you would get in a hydrological system. So we're trying to store that water in the catchment instead of allowing it to flow quickly downstream, downhill. So there's a few ways we can do this. The most natural scenario is that water infiltrates straight into the ground. Where this can't happen because the ground is not permeable enough, naturally that water would collect in ponds, in depressions, and slowly that would then either infiltrate to the ground or it would flow in watercourses through the catchment. But importantly, we don't get these really intense flows usually in natural environment. This is really only an urban phenomenon.
And one of the ideas is the idea of permeable pavements, of having a hard surface but that the water can flow through.
Exactly, trying to emulate what would happen naturally. So if we have an area where we want to have a hard surface, then we can just make sure there's avenues for the water to dissipate through the surface into the ground. So importantly, we need to think about what the properties of the ground are and what sort of systems we can design to be compatible with those properties. So for example, just to the west of Nottinghamshire, we have a sandstone bedrock. It's very permeable, and we can quite happily concentrate our water flow into a relatively small area, for example, into a soakaway, which is just a pit in the ground, and then that water can dissipate quite happily into the aquifer. Conversely, to the east of Nottingham, we have the Mersey Mudstone Group, which we're actually standing on now, and this comprises clay. It's really quite impermeable, and as we can see now, if we step around...
We're on a bit of grass here, and it's just muddy and horrible.
It's quite muddy and horrible, and here you would try pretty hard to focus any recharge rainwater into the ground. And so in a place like this, maybe you can install an infiltration basin that actually provides storage on the surface and allows that, therefore allowing that water to infiltrate very slowly. But actually what we chose here when we designed our new buildings behind us.
So we're on a hill overlooking, and it is really like a campus. It's like a university campus. They're fairly 2-storey, 3-storey buildings spread out, and we're on a slope of grass that goes down to them. So what have you done here?
So here what we've chosen is a rainwater harvesting system. So rainwater is harvested on our roofs and it's used to flush our toilets. And this is a good example of a sustainable drainage system which doesn't involve the ground. So we can install sustainable drainage systems absolutely anywhere. It's just that in some places we can infiltrate to the ground, and in other places we really should focus on either storing water on the surface or reusing it.
And what about the houses behind us and this area? I mean, I don't know whether this has particular problems with urban flooding. I imagine you get localised flooding just because the ground's not absorbing any of this water we've been having. But could you retrofit these sorts of systems?
Yeah, so here I suspect the water's going straight into the drainage system into watercourses. But certainly retrofitting is a big area of interest. In cities, when we regenerate areas, can we possibly put in sustainable drainage systems? And there's a real space issue here. So trying to find space for an infiltration basin is really quite difficult in quite urban areas. But still we can do things like put in permeable pavement, for example, instead of hard road surfaces, rainwater harvesting. There's always options.
And you've actually put together a map of where this would work in the UK and where it wouldn't work in the UK.
Not exactly, but almost. So we've created what we call an infiltration suds map, and this map shows you what the properties of the ground are. So we cannot say here you can install a soakaway or here you can install an infiltration basin, because it very much depends on the design of the actual system. So what is the surface area of the system, what is its volume? But we can tell you how permeable the ground is, whether you're on a floodplain, whether the groundwater is likely to be very shallow, whether if you put water in the ground you're going to cause a ground stability problem, or you could impact groundwater quality. And so the map gives you data that tells you all about these considerations so that you can then go away and make a decision about what sort of system might be appropriate.
But are there imperatives for people to do this, for builders, for planners, for architects, engineers, to take these sorts of things into account?
So the case with retrofitting is less clear, but certainly for new builds, there's a new legislation called the Floods and Water Management Act, and this requires that developers must consider using sustainable drainage instead of connecting to the drainage network. This legislation hasn't been implemented yet, but when it has been, it will mean that developers must prioritise the use of infiltration to the ground. So they must consider the properties of the ground, and they must consider using infiltration as the most kind of natural and sustainable drainage system. If that's not possible because of the properties of the ground, they then must consider storing water on the surface in infiltration basins, for example. And if that's not possible, then they may consider putting the water into the drainage network. But the key thing is that the right for them to connect to the drainage network is not necessarily going to be there in the future, and they are going to have to think of other ways to solve this problem.
And what about the cost of all this? I mean, on balance, is it cheaper to do this than deal with the cost of the flooding?
In terms of the actual, well, certainly in terms of the cost of flooding runs to billions and billions in the UK. So absolutely. When we look at a more of a site scale basis, the land take required for sustainable drainage is going to be greater than that for conventional drainage, and so there is some tension there with regards to developers and land prices, etc. But the benefits are very obvious in terms of reducing the flooding.
Rachel Dearden, hydrogeologist for the British Geological Survey. Thank you very much. This is the Planet Earth podcast. You can find us on Facebook, Twitter and Planet Earth Online, where you'll also find stories about fierce-looking armoured fish, as well as a study of Australian birds, which shows that having relations around to look after the kids lets mothers ease off and save energy for the next lot. To find out more, just search for Planet Earth Online. You'll find pictures on our Facebook page for our next story, which comes to you from the middle of an enormous field in the Norfolk Fens, about midway between Cambridge and the Wash. And when I say field, this one stretched to the horizon, bordered by muddy tracks and thin, straight lines of trees. This area of the country isn't everyone's cup of tea, but the expansive landscape and vast skies do have a certain appeal. I was there to meet Heiko Bolster, Sue Page and Ross Morrison from the University of Leicester. They have an experiment rigged up in the field to measure how much carbon this peaty area absorbs and how much it releases. It's the first time an investigation like this has been set up on farmland, and it'll be used to help improve computer models of the climate. Before we get into the science, I'll ask Sue first to set the scene for us.
One of the obvious characteristics of this part of eastern England is the fact it's extraordinarily flat. And the reason for that is because of the way in which this landscape has developed over thousands and thousands of years. This part of England receives something like a seventh of all the drainage water coming off England, so several very large rivers. And over thousands of years, this area developed as one vast floodplain fenland. And associated with that fenland has been the development of quite deep peat deposits.
And peat is essentially, it's just organic matter, really.
It's organic matter that has accumulated because the rate of deposition exceeds the rate of decomposition. And decomposition has been slowed down here because of the long periods of waterlogging.
And how important is this area, both in terms of the farming but also in terms of the environment?
The fens have been known as an area that can be used for agriculture for hundreds and hundreds of years. The most extensive drainage of the land began in the 17th and 18th centuries, and the reason for that drainage was because the land had a high agricultural potential. Initially probably for grazing land, but subsequently, of course, very extensive areas are now used for vegetable and also grain production.
Now, Heiko, you've set up your experiment pretty much in the middle of this field here. We'll talk about what that involves in a moment. But what's the big picture? What are you looking at here?
Now we are trying to get to the bottom of the carbon emissions that are coming off these soils under different conditions, both different land use conditions and extreme weather as well. We've had very extreme dry conditions last year, lasting until about Easter. And this year, of course, has been one of the wettest summers, I think, in the last 100 years in Britain. So we are trying to find out what that does to the carbon exchange between the land surface and the atmosphere. And the carbon emissions coming off the peatlands here, of course, contribute to the global warming problem. So there is the feedback between the land and the climate system, and we are trying to get numbers of emissions that are coming off the ground.
And initially you were concerned about drought, which seems daft when you think of the last summer, but the summer before it was extremely dry, and that was a big concern.
Yeah, we were concerned about the impacts of the drought when we wrote the grant application for this project, because it had lasted for a very long time and there were actually water use restrictions in place in many parts of Britain at that time. Since the grant started, of course, we have had extremely wet conditions, and I think under scenarios of climate change we can expect more of these extreme conditions in both ways. We can expect more droughts and more heat waves and more wet conditions like the ones we have experienced. That enables us to look at both the impact of the last dry year and also the impact of the very wet conditions over the summer.
So you're looking really at the contribution this area of England and I suppose the wider world, these peatland areas, contribute to carbon dioxide in the atmosphere and to climate change.
That's right, especially the agricultural land use, of course, brings some oxygen into the soil, and that helps the mineralization of the peat, which releases carbon. How much carbon is released depends on the disturbance of the soil by agricultural machinery, so how you manage the soil. And that is something the farmers are interested in, how they can best preserve the carbon by having sustainable farming practices, and also by the climate conditions or the weather in particular years. Whether you have heat waves or dry conditions or wet conditions influences how much carbon exactly goes into the atmosphere.
Now, Ross, you're responsible for the experiment here, which is cordoned off behind a barbed wire fence, a small area really bang in the centre of the field here. And it's a series of solar panels, I'm guessing for electricity. There is a substantial, almost like a fridge-sized green box, and then a very peculiar, I don't know how best to describe this. It's obviously some sort of weather instrument, but it looks like a weather instrument crossed with a whisk. What is it?
This is a weather station, but quite an advanced weather station. It's got all the elements you'd expect from a normal weather station. For example, we're measuring temperature, relative humidity, radiation and that sort of thing. But then the bit that looks a bit like a whisk is the more advanced part of this. What we have here is a device, an anemometer, that basically measures atmospheric turbulence. And then we have the other device, which basically measures the concentration of CO2 and water vapour in the atmosphere.
And you're measuring the carbon dioxide, coming off the peat and going into the peat? The exchange between the exchange of gases?
At certain times of year, plants take up carbon dioxide from the atmosphere, and throughout the year, soils basically lose carbon dioxide to the atmosphere. And so essentially, using this instrument, we can basically calculate how much is moving over a very quite high frequency. Sort of every half an hour we get a measurement from this, and then obviously over longer periods of time we can build that up to get an idea of how much carbon we're gaining at certain times of the year, and then losing at other times of the year, and then kind of the balance over time between that.
So when there's a crop in the field, spring, summer, then you'd expect the carbon dioxide to be coming into the peat, and this time you'd expect the carbon dioxide to be leaving.
Yes, at the moment there is there's a vegetation cover, but this is just coming back naturally. So this is natural.
It's just sort of nettles and weeds and bits and pieces.
Yes.
Yeah.
When the crop is actually growing, it does accumulate quite a lot of carbon. At least the crop we measured this year, which was iceberg lettuce, did on some parts of the growing season actually result in a net removal of carbon dioxide from the atmosphere as the crop was maturing. And then at other times of year, following ploughing and this sort of stuff, at this time of year when essentially most of the soil is bare, we'd be expecting to see a net loss of carbon to the atmosphere.
Heiko, this isn't the only setup you've got. You're looking at other sites as well.
That's right. We have 3 towers in total in the fens now. One is operated by the Centre for Ecology and Hydrology, and 2 are operated by the University of Leicester. They are covering a land use gradient with 3 different types of land use. One is in the semi-natural fen in Wicken Fen, which is one of the few remaining areas of pristine peatland in the fens. The second one is on a restored area, that is Baker's Fen, near Wicken, that is now managed by the National Trust for nature conservation purposes and is trying to re-wet the soil that was previously used for agriculture. And this third one that we set up this year is the first one that is on agricultural soil on farmland.
And how will the information from this be used? I mean, what do you want to do with it? I suppose it's understanding better the processes, but I mean, is there more than that?
Well, the United Kingdom, like many other countries, are legally obliged to report their greenhouse gas emissions to the United Nations Convention for the Climate Protection. Now, what this means is that we need data that actually show how many greenhouse gas emissions are coming from this area. And the current way that greenhouse gas emissions from this type of soil are estimated is using constants and tables of numbers that are essentially based on the best available knowledge. But nobody has actually measured it the way we have done. We are hoping to put a better accuracy on this data.
And how important is it to do these sorts of studies then?
Well, it has huge implications for knowing exactly the amount of greenhouse gases that is emitted from these land surface areas. First of all, because we need to understand the Earth system fully, and we need to know how important the greenhouse gas emissions are from this area to assess how important it is to protect the carbon that is locked in the soils here. Secondly, there is of course an implication for the farm managers, in the sense that we are trying to identify the best way of actually helping them to reduce and control their carbon emissions, which is in their own interest. And this is one of the motivations why this farm manager here has made the land for us available to install the instrumentation.
Heiko Bolster. You also heard from Sue Page and Ross Morrison, all from the University of Leicester. Pictures of that windy field and the peculiar-looking experiment are on our Facebook page. And that's the Planet Earth podcast, produced for the Natural Environment Research Council. I'm Richard Hollingham. Thanks for listening.